Okay, now coming to this, it says number of zero filled subarrays. We have to find how many subarrays are there which are only containing elements which are zeros. So if we look at this example, then in this example, we see two zeros are together. But if we look at two zeros, we can make subarray of size 1 by taking only first zero, subarray of size 1 by taking second zero, or subarray of size 2 by taking both the zeros. Same way here also. Now, if I just ask you, this was a simple mathematical calculation. Let's say if you have three elements, A, B, C together, how many subarrays are possible? If number of elements are 3, how many subarrays are possible? Okay, can you take 4? Okay, sure, Kumar. If we take 4 size array, 1, 2, 3, 4, how many subarrays are possible? Index 0, index 1, index 2, index 3. Let's say all are 0 zeros. So starting with index 0, if I set this as a starting point, how many subarrays are starting here of non-zero size? So Kumar, starting here is 0, 0 is a subarray. Do you agree? Starting at index 0, ending at index 0. Same way, if I start at index 0, can I end at index 1? That is second subarray. So total, how many subarrays do you see, Kumar, that start at index 0? Ending can be anything, but start at index 0. Okay. So you are saying 4. So can I say if the array was of size n, we can generalize starting at index 0, there will be n subarrays. If I ask you next, starting at index 1, how many subarrays you will find? If you start at index 1, you will find n minus 1 subarrays. Here you can see this is 1, this is 2, and this is 3. So n minus 1. And same way, if you start at the last index, if you start at index n minus 1, how many subarrays you will find? Only 1. And you have to count them all. So it is just about 1 plus 2 plus all up to n minus 1. All up to n, sorry, not n minus 1. So we just had to return the count. Now, if this is the case, if arrays were all filled with zeros, now here there were non-zeros also. So what we need to do is we need to focus only on those arrays which contain zeros. So coming back, can I say that when we are moving forward in this, first we find a subarray of size 2. If n is 2 here, okay, you missed contiguous subarray. Kumar says that. Yeah, it says subarray is a contiguous non-empty subsequence of elements within an array. And you had to return that subarray is filled with zeros. So if this array, if you consider is of size 2, it will have subarrays n into n plus 1 by 2. Here n is 2. 2 into 3 by 2. So you get 3 subarrays here. Same way here also you find a subarray of size 2, which has all the zeros. So this will have, yeah, it is 3 plus 3. So this will give you 3, this will give you 3. And in second example, if you look at, if 3 zeros are together, how many subarrays you will get out of these? It will be 3 into 4 by 2. 3 into 4 is 12, 12 by 2 is 6, plus again 3. 6 plus 3 is 9. So it was just a mathematical formulation by finding the start and end index. Now there is a corner case also. What if your subarray ends, like overall array ends with a 0? So you have to just account for that case. But since this is an easy problem, they had given this also as a sample test case. So all we need to do for this problem is you get started initially. First element is a non-zero element. So we don't have to worry about it, move forward. We are not considering that. This is a non-zero element, move forward. Now you find a 0. You find a 0, you have to find the size of array, subarray which contains all zeros. So here you will say, so far size of the array is 1. Extend it. Now again find a 0, the size became 2. Next element is a non-zero. So far, whatever count you got, whatever size you got 2, take 2 into 2 plus 1 by 2, add that to the answer and reset your count to 0 again. So it was mainly a problem of finding size of every subarray which contains all zeros, and after that it is just a mathematical formula. Okay, is there any other approach anybody used apart from one single loop of counting zeros? Okay, I missed this point and ended up with TLE, but did check how others have coded and amazed to see this logic. Okay. Yeah, because ideally, if you see, otherwise, if you enumerate every subarray, then we know there are n square subarrays, n into n plus 1 by 2 subarrays. That brute force logic will certainly give you TLE because input array size is 10 to the power 5. Okay. Cool. So this is our second question. Just in fact, in this we can have some learning. This is we should know what is number of subarrays of array of size n. That is one formula we needed, and second we needed was like locate part of the array having all zeros as a segment. This is what continuously we have to do. Okay. So shall we move forward to third problem?